Hi everyone. Hi everyone. Good afternoon. So welcome you to another live coding session. Um, we have few people here today, so hopefully people will join us. Or as usual, they'll watch this later on YouTube or something. So today we'll be continuing the live coding session, and like I stated in the last one, today we'll mostly be doing a continuation of what we failed to complete in the last stage. So our live coding session today will deviate a bit from the Kubeflow. So it won't be necessary, it will not be based on Kubeflow, but it will be based on Kubernetes. And what we'll be doing is we'll be completing the zip folder that I shared the last time. We'll be completing the Docker, because I think I've completed it, but we'll be going through the Docker files. We'll create two Docker containers, we'll link them up together, and then we'll look at two ways where you can use Docker alone to spin up these containers. And then after spinning up these containers using Docker and connecting them together, we'll then look at how we can place those containers inside Kubernetes deployment using Minikube. Okay, so without wasting much of our time, so let me go and let me share my screen. How to share my entire screen? Can you guys see my screen?
Yes.
Thank you. So documents. I think it should be under docs. Um, mm, mm, mm. Okay, so exactly it was this. So let me just open this in VS Code. Exactly. So I remember the last time we had gone through the process of creating this app. We have created app1.py. We have also created app2, and let me just place this on to ensure. So we had created app one. We had also created app two. So to ensure that these both of these apps were connecting and talking to each other. And what we had also done is that we had created images for app one and app two. So let me go to my Docker and let me confirm if I still have these images on my local system. So this is app one, the front end, and I think we also went about how we were using different tags to showcase different aspects of the app, where different aspects of the app, like when we were trying to start it and we were running into some errors. So rather than replacing the previous version, we just push new version. So that's why app one backend has version one, version two, version three. So that was another aspect of Docker that we showcased. Another aspect of Docker that we showcase where you can use tags to separate or work on different versions of the same app. So we have created this app. So now let's start by using this app. So just going over creating the app again. This was what we used to create the first app. So I remember the form command, working directory to create code. We expose the ports because we know we are running our code on this particular port. So we expose these ports so that other services from outside the container can access our app inside the container. Then we copied all our files, we ran the installing, and that was what we did. We did the same for app 2, and this is so we use the most. I'll just be using the most recent version of these apps. Backend V3 3 days ago. Okay, exactly. So this is app one. So app one front end. So app one front end. So let's use this to run a container. So we'll click on this, and then so we want to bind ports. Let's bind port 7,000 on our system. Okay, just to showcase, let's bind port 8,000 on our system to 7,000. So we'll call this uh front end container. So let's do this and let us run this. So if we run this, uh okay, fail to run. Port is already allocated, so we cannot use port 8. I think there's something. I have something running on port 8,000. That's shocking. So let me come back to these containers and let me see. No bind mount. So let me just delete this container and then let me remove it. Okay, so let me go back to my images and then upon front end, latest version is version 4. So I'll run this as usual, front end. Okay, and let me place this on. Let me place this on 3000. I think 3000 should be free. So let me run the front end here. So exactly, so our app is opening, and if I come here, click on my local host to open up my browser, you can see that we have our front end, hello world, we are here, and then in our front end we have endpoints like generate random, if I remember correctly. Okay, let me just check it out here. So in our front end is the app one. So we have show HTML, exactly. So if you come here now and do show HTML, so this is the HTML. This is another, this is a subheader, and if you also come, so where I now want us to see now is that because we have started our front end container, but we have not started our back end container. Let us try to run the show random. Let us try to show to run the generate number endpoints. Show random, sorry. So if I come here and click show random, we are going to get an error. So you can see, so there's an error. There's an error because the connection where we are trying to run, because there's no backend that is providing us. Because if you remember, what we did now is that the backend, so we send the request to the base URL, and the base URL is provided with an environment variable. So our environment variable for base URL when we were testing locally with our system was that we were running it on our local host, okay, on port 9000 on our local host. But now that I've moved into the container, on the container there is no backend running where on port 9000 inside that container. So that's why there's a connection error. So what do we have to do now? Our front end has been created. We have to start our backend. So now let us go and start our backend. So this is our backend. The latest version of our backend is v3. So let me play this also, and let me call this backend container. Backend container. So if we call this backend container now, one thing that we're going to have to do now is that we also have to set a port. So our backend container is starting on port 9000. Since we know that our port 9000 is taken, I think based on what I was trying to do before, let me try and use 4000. So let me run this backend container and I'll run this, and hopefully this should come up. So you see our backend container is also up. So if I come here now and click on this also, you can see that our backend, this is the backend. So for the backend, I think we have the endpoints get random or something. So let me just go there to get the endpoint. So we have the endpoints generate number. So this generates number endpoints. Okay, generates, okay, yeah, generates number. Okay, so we can see that for every refresh you are doing, a random number has been generated. So now now comes the major issue, because we have already started our container already. So there's no way. What we need to do now, we need to get a way that we can let our container understand that the backend is now where it has to look for the backend on localhost 4000. So there are a lot of ways to do this, and that's what Kubernetes always helps us to do. So if I come here now, one way, the first way that we can do this is we can go into this container that has been created, the front end container now. Okay, container, front end container, come into the container, and I can now start to provide uh I will come and try and give it an environmental variable. But the issue with all of these things is that before you can set an environment variable, your container has to stop first. You get, your container has to stop. There are two ways you can do this. Apart from setting an environment variable using Docker itself, because we are copying our environment variable, we can come here now, okay, inside this code, I can come here now, this environment variable here. Okay, I can come inside this environment variable here and change it. Let me do this. Let me edit this file. So our environment variable, we now know that where you can get our local our where you can get our backend is now on port 4000. Abi, let's come here and change this to port 4000. Okay, and now let us save this. So we have saved this and our environment variable has changed. Now let us go back to our front end and try to see if our front end will give us what we need. So that should be the show random, and I'll click on enter, and you can still see that we are still getting an issue. We are still getting to an error because it is still trying to read it on port 9000. So why is this happening this way? Is because when we go into our code, you can see that the only time that we are reading our URL, we are reading our URL just once. We don't read our URL every time we are calling the show random function. We read our URL immediately the app is starting. So it means that the URL that gets read whenever this app has started, basically the URL that gets read in when the container has started is the URL that will be used for the lifespan of that container. It is that same URL that we're going to be using for the lifespan of that container. And the only way we can now direct our front end, the only way we can now direct this particular front end container to now start reading from the backend container that I've created is to now restart this container and provide it. So how do we do this now? Another thing I also want you to know is that when I think I must have mentioned this, but you can see that in this stuff, I just edited this file, this environment file. So if I open this environment file now in this particular container, if I click on edit, you can see that the port has changed to 4000. So what will happen now when I stop this container? Okay, let me go to my container. So this is the front end container. Let me stop it. Okay, so now that the container has stopped, if I start it again, that same container, now the container is running. Okay, it is still running on port 3000. So if I now come back here and refresh show random, you can see that we are still getting an error. You can see that there's still an error here. So what is happening? Why is there still an error? Because using using localhost, telling it to run localhost 127 blah 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 4000, is as if you are telling it that in that same container there should be an app running on port 4000. The reason why we are trying to see this so that you can see that every container that you create is isolated from each other, even though the containers are in the same PC. This container is running on my PC. This second container is also running on my PC. I went into the environment variables of this first container, the front end. Where's my Docker? I went into the front end here, this container, the front end container, and I changed in the files. I changed that. Okay, since we are using our URL from this particular environment file, okay, let us change it to be on the port that our backend is running on. But you can see that it is still giving an error because this method is only seeing it as though what? As though we are providing a URL inside the container. So this cannot work. We now need to let this container to be able to access another container that is outside. So how do we do that? So that's one of the issues when you are running microservices architecture, when you are spinning up different containers, like spinning up different containers separately. You have to want to stop one container. When you want to stop one container, you have to stop one container before you can connect it to another container. And this is what Kubernetes gives us. When you start using things like Kubernetes, in Kubernetes, because Kubernetes is the one that is spinning up each container, it automatically, you don't have to stop one container to connect them to each other. So imagine we are doing all of this manual process now. So because of this now, there's no way this container can communicate with this container. What we have to do is we have to now delete it. Okay, no, don't let me delete it. Let me see, try and do it in-house. So there are two ways that we can do this now. The first way is I will delete this container because this container, you cannot communicate with it. So I'll delete this container and I'll now start a new container. Okay, so what I want to do to start a new container now is that when I now want to use this image to start the container, okay, front end container. Okay, what I want to do, we are still going to place it on 3000. So what I'm now going to do is that instead of using the env file that was inside the container, I'll be passing an environment variable to the container itself. So the order of precedence is that if you have an environment variable here, this environment variable should supersede the one that is in the environment in the env file. At least that should be how the order of precedence is. So if we go back to this environment file, this file here, base URL, so I'll copy this base URL here, and then I'll paste. So these are our base URL. So instead of passing 1.2.7 point something now, what I'll now be doing is, I know we have our backend container. Our backend container is called backend container. Okay, I have to ensure that I have the correct name. So let me get the backend container. So this is our backend container, Abi, and our backend container is called backend cont. So this is it here. So let me just pick this name, backend cont. Okay, let me pick it, Control C. And now let me now try to create a new container from the front end. So to create a new container from the front end using v4, I'll do this. So this new container will be called front end container, and then it's also going to be on port 3000. But now our base URL, okay, base underscore URL is now going to be gotten from the backend container. And in the backend container, let me see, how do we provide the base URL? So we provided the base URL, the full, and the port. So what will happen is that now, instead of providing something like HTTP blah blah blah, we are now providing our backend, that container itself. Now we are seeing that container itself as something that you can access. So this is when you say backend container, this is like you accessing the local host of the backend container. Okay, and then you should now add the port. So on the inside the backend container, where what port in the backend container is our something, is our app being run on. It is being run on port 9000. Even though in our local host here, on our local host, when I come here to get the backend container, I'm getting it on port 4000. But in the backend container itself, the actual port that the backend container is running on is port 9000. So I'll click on one, and the expectation is that now the front-end container should be using the base URL from the environmental variable, the environment variable that we pass to it. Okay, so I think we should be able to see the environment variable somewhere around here. Mount config, exactly. So this is you can see this is env. So this is where the env is. So in the env, what we have passed in, all of these are default environment variables that were set up, blah blah blah. But now we have passed our own environment variable called base URL, and it is on the backend container on port 4000. So now let us try and run this. So you can see now there's still an issue. It is saying that you can see that the first thing is that okay, successfully the backend container, the base URL has changed now. It is not trying to use 127 dot blah 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 localhost to access the backend. It is trying to use the backend container, but there's still an issue. It does not understand what backend container is. It is not able to see the backend container itself as what? It's not able to see the backend container as a service or as a URL that you can access. So why is that? So the reason why that is that before this can work successfully, you need to create something called a service with Docker. So if you come into this deployment file that I have here, okay, so this backend deployment, blah blah blah. So this combined deployment, blah blah blah. So you see that there's something. This is the front-end deployment. So this is something called, this is an example of what a service is. So this is a service. So what the service does is that your service enables you to allow different containers to communicate with each other. So you can see that previously on our local system, we did not have to use like extra. What we just needed to do was to say that on this our local system, when we're testing locally, we just had to like say on the local hosts, all you have to do is that go to this particular port and you can see um you can see what do I call it? Go to this particular host. You can see this particular on this particular port. This app is running on this particular port. That's what we did on a local system. But now that we are moving into Docker containers are isolated. So we need to provide something that can make that Docker container itself act as a local host that another container can start communicating with it. So to create that, we'll come here, okay, and we'll be using the Docker service command. Okay, so to use that, I think uh I'm trying to get the particular command that we use here. Okay, so let me just do something first. Docker images list. Okay, I'm not saying I want to see all my images exactly. So these are all of my images. Okay, so to create a service now, we're going to be using the Docker command. So I'll come here. So this is Docker service. Then I'm creating the service. So let me use the help tag so we can read a little about what this command is going to be doing. So you can see this is quite long. Okay, so what does this do? This creates a service. So these are all of the tags that you can use: environment list, blah blah blah, the different kind of thoughts that you can do, the host list, one or more custom host name string, container host name, and all of those kind of different stuffs. But what we need on our own aspect is that when we want to create the service, we want to specify a name for the service. So if you come here, you should see something name. I think DEIJKLM. Exactly. So this is the name. So there's the name. So we are going to name the service so we can easily access this service. And then after using that tag, then we need to give it the image. Okay, the image that we are creating the service for. So what is going to be happening now is that I'm going to come here. So Docker service create. So the name is going to be backend service. Okay, and then the image I'll be using is our so let me come here to get our image name. So our image that I'll be using is the Adenion. I'll be using this backend image, this one. I have two backends. So the image name is Adenion, okay, slash app2 backend, and I also need to specify the tag. So let me confirm that this is correct. So Adenion slash app2 backend v3. So you can also use this as the image just in case this is the image ID. Well, it's better to use the image name. So with this, a service should be created. So to connect to this node. Don't get this should not be let me just probably check that documentation. So, okay, so I don't know, have they updated how they do this? Should be working for an image. This node, let me see. Docker PS. Let's go to their Which comb I feel use like this now? Okay. Previously, we used to be able to do this, but then I think we will have to use a Docker Compose. Because what I wanted us to be able to do was to the app network. Hmm. What I wanted us to be able to do was to not use Docker Compose because with Docker, let me just look for a Chrome exactly. Let me use this. So there's something called Docker Compose. Okay. And then what Docker Compose does is that Docker Compose helps us to spin up multiple images in one container. Okay, so rather than with Docker Compose, rather than having our front end container as a separate container and our back end container as a separate container, what will happen is that there will just be one full container. And what that full container will now have sub containers where every image you have specified in Docker Compose, because that's the standard. But previously, before Docker Compose, we used to be able to do this without having to use Docker Compose. So I don't know, maybe um they have updated their methodology to just make Docker Compose the standard. But let me learn Docker commands. So let me just see. So this is the Docker engine. Okay. Or have they created this to Docker network? So Docker, I understand all of this. So the Docker engine containers. Okay, so I think it's networking. So it's under networking that we're going to use this. I think that's the update. Previously, I think it used to be under service. So you can create a network. I see. So the latest update now is that you need to be able, you are going to create a network. In addition, user defined network, you can attach a container to another container's network stack directly using the network container. I see. So this is on its network. Blah 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 blah. Okay, so let's try and do this. Let's create a network for this other one. So what I wanted to do before was create a service, but then seems we have to create a network rather than a service. Okay, so so let me create a network between this. So Docker network create. So let me just call this app network. Oh, sorry, that's a typo. So net O before R. Okay, so this network has been created already. So now that this network has been created, I'm now going to have to run uh I'm going to have to run the backend container and the front end container again and add both of them to this network. Okay, so let me come to my Docker. Let me stop these two containers because I need to stop them. Okay. Um, is there where we can see the network? Let me see. That's not being shown here. But let me stop these two containers. So backend container, I've deleted this, and then front end container, I've deleted this. Okay. So now we're going to be using the Docker commands to spin up these two containers. Okay. So what I'm going to be doing now is I'm going to be doing Docker run. So if you have an image already and you want to run an image, all you just have to do is to do this. So Docker run um so let me just show you. So everything that I'm doing won't seem as if I'm just writing code. So this is the Docker run command, and what the Docker run command does Let me raise this up a bit. So what the docker one command does is that you use the docker one to create and run a new container from an image. So we have our images. This is I don't want. Okay, let me just, probably I should try and sort this, but then yeah, this will be like my list container. So we have our images, our app2 backend, the version app2 backend version 3, okay, and we have our image app1 frontend version 4. So we are going to be using these images to run the docker container. So apart from this, so that's the docker run command. So the d command, detach. So what we want to do is, when you do the docker run command, is not is going to wait until the container is run successfully before it stops execution on your terminal. So if you know that you don't want to wait for the docker command, because if you do docker run, what will happen is that when the container is started successfully, you will be you will now have access to the bash of that container. So you will not have access to your normal terminal. You have to create a new terminal. So the d command is just that run the container in the background. So if you run the container in the background, we can perform other actions, and we are sure that the docker container is running already. So that's the d command. And then just like when we're trying to create a service, we have the name command. So this is the name command there. So we just use it to assign a name to the container. Sorry, that's the name command. And then so after the name, we'll specify what the name of the container is, and then you now see that there's something called the network. So what is now going to happen is that you can now add what this particular container, you can add it to the network. So every container that you are creating, when you specify a network tag, what will happen is that each container will be added to this network, and you need to specify the ports for that particular container. Okay, you need to specify the port for the command, and then whatever it is you are going to be doing. So that's what is going to happen. So let's come here now, and now let me use the docker run command. So docker run, I'm saying d because I want to detach this container when I'm running it, so I don't have to wait or get into that particular container. So the name that I'm going to be giving the container, I'm going to be calling it, so let's start the backend first. So I'm going to be calling this the backend container as usual, and then this backend container is going to be on the network. Okay, now that the backend container is going to be on the network, I'm also going to provide p. Okay, so what p does is that, when we are trying to start a container here, when we are trying to start a container using this image, when we click on the play button, when we are this optional settings, so this port, this space where we assign ports to ports. So because I think I must have mentioned this before, every GUI tool that we're trying to use, there's an equivalent for it in command line, basically. So if you want to provide the ports for an app, or you just need to use the p command, and then the first port you are going to be providing is the port for your local host. So just like we have here, where we provide the port for our system that we want to connect to the container port. So the first number we're going to be having is the number on our own container, on our own local system, sorry. And then the other number on the other side of the colon is going to be the port inside the container. So since we know that the exposed port in the backend container is 9,000 here, okay, so I'm going to be saying we are running on port 9,000, are connecting 4,000 to port 9,000, and then we'll be using the oadenio slash app2. Let me just confirm. App2 backend, the version 3, basically. So that's what this is a command to run a container. What we have been doing previously, where we run containers using the GUI, this is the command line equivalent. So the command line equivalent is this is the container, but the major difference now is that we're adding the network. See me, I forgot to specify what the network is. So you need to create a space. And what did we call our network? We called our network app network. So yeah, I'm going to say that this is going to be app. This is going to belong to app network. Okay. So if this belongs to app network, I'm now going to run this container. So you can see that this container, so what I'll try to do is, maybe I should try and run the next one without using the d command. If I don't use the d command, you see that this will wait until the container has started. And after the container has started, that's when you will now have access to the container. So you can see that we already have who are then your app2 backend, you see it is running already as though we are done it with the GUI, even though we are done it with the command line interface. So to ensure that it is working, so let's use on 4000, you can see that the backend is working as expected. So we have successfully run the backend container and added it to that particular network. So what we need to do now is to now do the same thing for the front end container. Okay, but one thing, so let's come here. So we'll call this first, changing the name front end. Okay, so that's the front end container. And then aside from the front end container, we are going to be binding port 5000. And we also know that on our front end container, we are starting it on 7000, the ports to bind. Let's just confirm. If you come here, if you want to start a front end container and click on play, what you have here in your optional settings is 7000. Okay, so one thing that we now need to add now is that for this front end container, we now need to also add a what? We need to add an environment variable. So let us go back to this particular um let's go back to this particular help stuff here, and let's see how we can add an environment variable when you're trying to run a container. So you can see the E. So there's an E command, and to use the E tag, all you need to just is to provide the environment. So if I just do EE, so to do that now, okay, so let me see, do I provide command arguments? So after specifying the image, you specify the command. So these are options. So does the E fall under options or commands? So E falls under options. Okay. So the options, the image, the command, and the argument. So since E falls under options, so I'm going to come here now, and just before the image, I'm going to add this called env. Okay. And under this env, I'm now going to add this base URL. Okay. Sorry, can you hear me now? Hello, can you
Yes,
guys hear me?
yes.
All right, yeah. So to now add the to add an environment variable, so I'm going to be using the env command. Okay. So to add the env command, so I'm going to be using, let me just use the E. Let me confirm. So env, okay. So let me use the env double dot env. Okay, and then to add the backend URL, so we called it base underscore URL, and it is equals to. So now that if we want to add the base URL, what are we now going to add? We are, because what we are trying to run is the front end. Let me just change it so we'll not have an issue with the image. So this is the front end. Okay, and then this is app one. The front end, this is app one, and then the version we'll be using is version 4. Let me confirm that here. That okay, the front end, the latest version of the front end, who are then your app one front end but v4. Okay, so because we want to provide this base URL, so now that both of them are on the service, we can now do this HTTP. Okay, as if we wanted to access a local host, for example. So HTTP, so this is the password, and then so now I'll now be able to pass this backend container, backend. Okay, what did we call it? We called it backend cont. Okay, so this is the backend cont, and then I also need to provide the ports. So when you go into backend cont, you need to go into what 9000 on backend cont, and that's when you can access this. So if this command is correct, then we shall successfully. So you can see we have done this. So if we go to this container, you see that we already have a new container called frontend cont. And if we enter this container called frontend cont, if we inspect this container and we go down to check the environment variables that we had there, you can see that our base URL, HTTP, backend con, blah, 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 is there. So the hope now is that when we go here and we, okay, let me just use this. So in this container, when we are click on this, the hope is that, okay, this is the front end. Then if I do the generate, okay, not the generate, I think it should be show random. If I do the show random, you should see a random variable. So you can see that now we have been able to successfully connect our front end and our back end inside the container using Docker. So these are two images. Sorry, these are two containers, the backend container, the front end container. Both of them were created and we placed both of them on the same network. Then after placing both of them on the same network, we have to ensure that we provided an environment variable where inside that environment variable, we provided that the name of the container as a website. So the name of, so when, even if you want to connect 3, 4 containers, if I want to connect another container to this, all I just need to do is to repeat the same process. But now, when I'm adding it, I'll just make sure that I add that same container to the network, and I need to pass the environment variable to access its HTTP backend container. So that's how we can do this manually using just Docker and everything. So up to this point, does it make sense? If there any question or something at this point, can you guys hear me? I said up to this point, any question? Should I take that as no questions for now, as everything is okay? Okay, so can you guys hear me? Maybe sure that these guys can.
Yes, 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 I can hear you.
Okay.
I don't have. It's not that we don't have. I don't have questions, but questions are too much. So let me just do this.
The questions are too much.
Exactly. So just don't worry. Just continue. Maybe I would have to go and watch the video again.
Yeah, that would probably just, you might just have to like go through the video again, and probably before going through the video again, try and probably refresh yourself on the previous one, because this is not where we started from. We had first started the process of creating the apps, linking them up and stuff like that. So if you don't have that context, this might be a bit hard to follow. So you might try and watch, that was like last stage for stage B. Then just try and go through that video so you can get, let me see, is there anything on the charts? Okay. So yeah, no problem. So that's it. What, so basically we have, for guys that have that understand what is going on here. So what is happening is that we have a backend, and then in the backend we have these endpoints. Show random. Sorry, I think it's Generate random or generate number, whatever. So this is generate number, and what this does is that we now connected this front end to the back end. It could have been final. I could have used like HTML or something to try and make it final, but then that's not the focus. The focus is to just connect them, and you can see that if we come to this Docker here now, if we come into this backend container and we are checking the logs. So did I ensure that I printed the number? If I refresh this, I should be seeing the number printed out. Oh, unfortunately not. I've removed that aspect of the logs. But what's happening is that the backend is running a get, and then on the backend container, we're just seeing this number that is created for every iteration is being shown on the front end. So that's how we do this manually. So because of, you can see how tedious it is to do this manually, or in the event that one of our containers stops running. So let's say there's an error, the request module that we are using in one of our app, they updated their module, and because they updated, oh okay, because we have ensured, I don't think updates, that's not the best scenario to say our container stop. So let us say exactly, we are hosting our containers in a virtual environment, and the virtual environment had a downtime. So due to the downtime, when they fixed the downtime, one of our containers stopped, and they could not automatically restart it, or when the containers got restarted automatically, the container just started. We did not provide, because when the whole environment started again, the network has changed. Because the network has changed, the containers were not on the same network anymore. So imagine how tedious it would be to have to try and stop each container, or let's say we want to make an update to our backend. So we have to like first stop one particular container before we can make any updates that will be showing. That's when it is being done manually. So to take away all of this hassle of doing it manually or stuff like that, that's why this stuff here called Docker Compose came up. So what the Docker Compose does is that with Docker Compose, I think I opened it up a while ago. Yeah, with Docker Compose, okay, so let me come here. So close networking, close engine, come to Docker Compose. So this Docker Compose. So what Docker Compose? It works in all environment, blah, blah, blah. It simplifies the control of your entire application. That's what it is. So what Docker Compose does is it makes it so imagine we had to like create a network every time. Imagine a microservice architecture where you are working with up to like 600 containers, or if 600 is overkill, let's say 20 containers. So we do have to start writing, or in whatever configuration file you're trying to do, you have to start writing this same configuration for the 20 different containers, and to try and ensure. So that's it, it's tedious. So what if we have a tool where that tool can be used to streamline the 20 containers at once? Every change you make to that particular environment will affect each of the containers as long as you have specified it. So that's what Docker Compose does, and it is very, very easy to use, and it works based on your Docker file. So what will happen is I'll stop these two containers. So you can see that if we come to containers now, we have the backend container, we have the front end container, two different containers here. So I'll delete these two containers here. Okay, and then I'll go back to our file here, and then I'll write something called Docker Compose. So to use Docker Compose, Docker compose.yaml. Okay, so if you want to use Docker Compose, you work basically, let's go to the website once more and how Compose works. So as long as you have Docker installed on your system, you can use Docker Compose. So you can see this is basically an example of what we are trying to do. So an illustrative example, blah blah blah, Docker Compose, but this what they are trying to do is two containers, just exactly the front end, the back end, the network. So there's basically the front end service and the back end service. Then this to a for system volume, blah blah blah, all of this. But this is basically what we're trying to do, where we have a front end service that interacts with the user, and then the front end service is the one that interacts with the back end service with a network. So these were all of the things we have to do manually. So using it to use a Docker container, a Docker Compose, for example, is just different. Let me just pick up all of this example that they provided here, and then let me paste it here, and then we'll start editing it. So basically, the first thing when you want to start a Docker Compose is you need to start with a services section. So the services section lists all your containers that you want to have in the Docker Compose. Basically, that's what your services section is. So any container you're going to be working with needs to be present in the services. So if it's not in the services, you will have a YAML error. So this is for people that are using volume. We are not using volume. In our own case, volume is we want to persist data, so that when you make any change inside your Docker Compose, in your Docker container, you can persist that change. But we are not going to be doing that. So I'll take this away, and then all of these configs, blah blah blah. I don't need all of this actually. So I don't need all of this actually. The only thing I'm going to need here is this networks. Okay, so the only thing I'm going to need here is this network, and you can see that they have two networks in this Docker container, the front tier network and the back tier network. So that's like them trying to even create an over streamlined version. But what me I just need is just the two containers, okay, the front end and the back end container, and then I need the what? I need the one network to back both of them together. So for example, so the front end, all you just have to do is our image. Our image is oadenion, okay, slash app1 called front end, okay, version 4. That's our front end image. And what port do we want it to be? We want it to be on port 3000, but we know that our container is going to be running on port 9000. That's for the front end. Okay. And then what network do we now want it to be on? Basically. So if I'm going to change, let me just change this here. Let me say, let me call this, instead of to use the same thing, let me call it app network. App network. Okay. So this is going to be, I don't need secrets. This is for secrets. I don't need the configs also. Okay. So it's just, I know that I just need the image name. That's the image I'm going to be using. Okay. And apart from the image I'm going to be using, I need the ports and then the network. So the network here is app network. That's just it. And then in this backend, so but I need to add something here to this particular one. I need to add environment variable env. Okay. So because in the env, I need to add that base URL. Okay. Base underscore URL is going to be equals to HTTP. Let me just pick this from here. Control C, exactly. And yeah, so now because in this our services are going to be named front end and back end, or to just have the same thing, let me name this front end container, let me name this back end container also. Okay, so this is the backend container, is going to be on 9,000, and then our image for the backend container is also the same oadenion slash app2 backend. Okay, and version 3. So let me just confirm that here in our images, our front end is app1 version 4, and then our app2 backend version 3. Okay, so for this I don't need volume also. I need to add the ports to this also. So that's image, then ports. Okay, so the port for this one is going to be, let me see, this dynamics, I'm having an issue with this particular, because it should also be able to showcase it just like it is showing this image, the image, the ports, the network. It should also have, it should also be able to show something here. I'll just try and get that data. So the port for this one is going to be, let's make it 5,000, and we know that our backend is on 7,000. Okay, I'm also going to be adding it to the app network. Okay, so if this is going to be added to the app network, then I think this is majorly everything that we need. So but one thing that we can try to do is to, because the way these containers will not get started at the same time, depending on how large the container is. Docker Compose will start everything at the same time, but some containers might get finished first before some other containers. Okay, so let's say one container in a Docker Compose, one container is 4 gig and the other container is 2 gig. Definitely when you are starting these containers, the container that is 2 gig will most likely get started and finished faster. So the container will be moved to a running state, because containers creating, after creating it gets created, after created it's running. So containers, one container might be, I believe we should be able to see that here. One container might be in the starting or created state, while another container is already in the running. So if one of your container, for example, we know our front end needs the backend container to be started before the front end can work. If peradventure anything is wrong with the backend, our front end container will not work, because it will not be able to call the backend container. So there's a key that is called depends on. So what that depends on does, you can see this depends on. So depends on ensures that this container, the front end container, will not get started until the backend container is working. That's basically what this does. So we need to provide the name. So this is backend container. So with this now, we have told Docker Compose is able to understand that if the backend container is not working when it is trying to start all of these containers, then there is no way you should start the front end container, because we need the backend container to be working before the front end container can work. So let me try this here, and let me do E. So you can see, so I think what I'm meant to use is environment instead of env. Exactly. So I can delete all of this, and yeah, this should be the correct one. So this is an environment variable that will be included into the container. So this is the, so I'll just save this, and then to make this work, so what this does, what this does is, there are two ways that I can use Docker Compose. If, because we have built our images previously, that's why we are doing this. We are just providing the images. But in a case where you have not built the images before, or the images are not on your local system, or the images are not publicly available, okay, you can also include something called build. So if you include something called build, with that you'll be able to ensure that if Docker Compose cannot find that container, it will build the container itself using the Docker file that you have created. We don't have enough time. I'd like to show it to showcase what that can do. What I'll have to do is, like, I would have to delete all of these content, these images that have been built. Then I'll not try and run the Docker Composer. But because we have these images, we don't need to specify the build aspect, because we are sure that these images are existing already. So what I just have to do here now is to now do Docker Compose. Let me ensure that this is the command. So you can see this Docker Compose. So you have Docker Compose build, you have Docker Compose down, blah blah blah, Docker Compose queue, blah blah blah. But what I need here is the Docker Compose up. So when you use the Docker Compose up in your root folder, what this does is it immediately uses, you can see, it immediately uses the Docker Compose, and the first thing it did was it created the network first, because it knows that the network is needed. And the next thing it did was it created the backend container. So the backend container was created, and then after that it created the front end container. So it now attached the the backend container and the front end container to this. So you can see, this is what I was trying to say. When you use a Docker command and you don't provide the task, you can see that anything we are trying to do now, we cannot do it, because what is just going to be showing here is the logs of the containers that we have created. So we can't, so to do anything now, we have to come to a new PowerShell before we can start. So that's why when you want to run commands and you know that you still want to do power, is either you create a new terminal for your PowerShell, or you provide the detach option. So if I come here now, if I go to our Docker stuff and we click on our containers, you see that there's a difference now. The difference now is that instead of having front end container separate, you can see this is the front end container, this is the back end container. Instead of having both of them showing like separately in this place, both of them are showing under something called DELCS. Okay, so what's DELCS? You can see that DELCS just refers to the name of this folder. So when you are using Docker Compose, whatever your parent container is going to be named is whatever folder your Docker Compose is saved in. You can change it in your Docker Compose file in your configuration that I don't want you to use the folder name. But if you don't change the default configuration, the default setting is that whatever you name your parent folder where your Docker Compose file is contained, that is what your parent container is going to be named. And you can see now that in our DLCS, we have both our front-end container and back-end container. Both of them are running. So if I click on the back-end container, for example, if I click on this page isn't working. Let's see, there's an issue. But this is starting as expected. So, or is it the backend that is on 7,000? Front end. Oh, I see. Yeah, I have an error here. So you can see that for the front end container, it's the front end container that is starting on address 7,000. Meanwhile, the backend container is starting on address 9,000. But when I was mapping, I mapped that the backend container should be on 7,000, which is wrong. So that's why you can see when you are mapping, you have to ensure that you know the ports in your container or in your Docker file that is exposed. If not, your container is not going to work successfully. And now, instead of having to delete, if I just come here and do Docker Compose down, okay, if I just do Docker Compose, so they have two options. Docker Compose down will just stop the container, but it will still be existing. So if I do Docker Compose down, what will happen is that you can see it is stopping the container, it is removing the container, and it is removing the network. But if I go to our Docker container, it has been created successfully. So you have two options, either Docker Compose down or Docker Compose queue. So if I want to ensure that this is correct now, what do I have to do? I have to come here and change the backend container to be on 9,000, and I have to come here to change this one to be on 7,000. So I know that the backend container is on 9,000 and the front end is on 7,000. So if I save this, and now to showcase this, let me try and rename this folder. Can I rename from here? I don't think I can rename from here. Let me see if I can rename it from here and to reflect directly. So let me call this apps folder. So let me rename this and call it apps. Okay. Exactly. It cannot open because it cannot get to name because it's open in VS Code. Well, that's by the way. So if I come back here now, you see that this container has exited. So let me see if Docker Compose has the detach function. So Docker Compose help. Let me see if it has a detach. So if it has a detach, that's all we just have to do. We just ensure that it is detaching. But then I don't think it has a detach where you can run this without getting into the container. So let me just do the same. Docker Compose up. Now our containers have been created already. This has been created. So now if I come back to our containers here and I click on DELCS and I go into this, if I click on this container now, so if I click on the backend 5,000, 9,000, you can see that we can see the backend successfully. The backend is showcasing. I want to exit all of this exactly. So you can see that the backend is showing, and if I click on the front end, so the front end is showing on port 3000. Okay, and if I immediately try to do the generate number or the show, I think it's show random. Show random. So you can see that our show random endpoint is working. So our show random endpoint is working because the Docker Compose automatically it creates the network that is required because you have specified everything in Docker Compose without having to ensure that you create one container first, ensure that the container is added to the network before you now start linking them up together. So that's the major difference. That's Docker Compose. So the last thing which we are going to be doing in our next live coding session, our time is fast spent, is that we'll be going into this instead of using Docker Compose. Docker Compose is basically what we're going to be doing with Kubernetes. But with Kubernetes, instead of using Docker Compose.yaml, we'll be using the YAML file that we have named backend deployment YAML. And this time, instead of deploying as a Docker container with Docker Compose, we'll be deploying them into a Kubernetes cluster using Minikube. So that's the end of our live coding session today. The next session is being held up, so we'll meet in the next live coding session. Thank you guys for your time, and bye bye for now.